to do this is by doing it over and doing it over until you finally get it. Do different examples. All right. So I did this one already yesterday. I think I did it in this class. It's one of the problems on your homework. Simplify the trig expressions. Yeah, you're like, I still don't get what you mean simplify. Imagine that this was secant was x. So if somebody said simplify this, maybe what do you think this is gonna? What do they want you to do here? Simplify. Multiply it out, no? Maybe we get something. So what this is like algebra and geometry put together, and so that's kind of what we have here, and it's what's called trigonometry. All right, let's go. I did it yesterday. Secant times secant, secant theta times secant theta is secant squared theta. You're foiling it out. Minus secant theta. Then you FOIL this. Plus positive secant theta. And this is going to be a positive 1 to the negative 1 is a negative 1. And this cancels out. Then you got secant squared theta minus 1. And so secant squared theta minus 1. There is one of the 8 identities. There's a lot more. There's more identities. But that's the only ones we're doing in Algebra 2. Where we came up that there was a tangent squared theta plus 1 equals secant squared theta. Yeah, I told you, didn't you have them here? Did I tell you, like, put them here? I had them right here. So you'll know that we can then maybe do something here. What can we do here? So we can have secant squared theta minus 1. What should I do in this equation? Minus 1 here, minus 1, this cancels out. If this cancels out, then tangent squared theta will equal to secant squared theta minus 1. That's why this turns out to be tangent squared theta. And so that is simplified. This thing simplifies to this. But then it goes to like, which one is more simplified? How do you know that that's not simplified and this is more simplified? Yeah, there's nobody can tell you. This looks more. This is one term. This looks more simplified than this, but whatever. Yeah. So that's it. That's it. Look. Okay. So how I think today's lesson is easier. Now I don't know what that means. What's easy, but I'm going to give you some suggestions. Go ahead and write this down. Let me give you suggestions in doing this. All right, here are the suggestions. Write it down. Suggestions for verifying identities. I think this is a little easier because you already know what you want to do. All right, I'll tell you when we start. When we do an exact problem. Here's a suggestion. Change all the functions to sine and cosine. Sine and cosine are the most basic of trig. Tangent, maybe. And then the other ones are cotangent, cosecant, secant. Those are the reciprocals of them or whatever. But these sine and cosine are the most basic. Simplify it to sine and cosine. So write them out as sine and cosine. Here's an example. If you have tangent theta, what is tangent theta equal to? Anybody? What is tangent theta equal to? But see, hold on. Yeah, okay, you got two of them. Yes, you do. But let's follow what this is saying to do. What is it telling you to do? Change everything to sine and cosine. So what is the answer to that when it tells you to change it to sine and cosine? This is this. That's a suggestion. It's not some. The thing about it is not that all the time this works. It depends, but that's just a suggestion. All right. Number 2. If you have a complex fraction, simplify it. Here's another example. Say you got something like this. You got tangent theta over secant theta. As it is, it's not a complex fraction. But we will make it. Let's make it into a complex fraction. All right. How are we gonna? Because something's gonna happen here. What did I say from the previous example? From suggestion 1, what do we change tangent theta to? What did we change tangent theta to? Sine theta over cosine theta. So we already are using suggestion 1. Suggestion, this one here, what's secant theta equal to? Well, we're still going to be using, change everything to sine and cosine. We're still going back to 1. What is secant theta equal to? 1 over what? 1 over cosine theta, yes. Now what can we do? Then look, then things reveal themselves. Then you're like, oh look, we can do something. We can cancel cosine and cosine. So the answer is sine theta. So you just gotta do this over like a lot in practice and do it, and then it just kind of like you get patterns, and then you know what's gonna happen next. Number 3. If you have 2 fractions with a plus or a minus between them, add them or subtract them depending on what it is. Here's another example. So yeah, this section of trigonometry called identities and verifying identities is a very more abstract. You really need to know a lot of things from elementary school math, middle school. You need to know algebra. You need to know geometry. Here are 2 fractions. Do we have a common denominator? Yes or no? Yes? Yes, we do. So we're going to put it under one of them. I always say put it under one of them. So we have a common denominator, put it under one of them. And what's the answer going to be on top? Tangent squared theta plus 1. And you already see that something can happen there. Yes. Then it's after doing so much, things start revealing themselves, and you start getting something. But we're going through the suggestions, all right? So I'm going to stop there because we're going to go on to the next suggestion, what we're going to do now. And it says, use any known identities to simplify it more, which is going to be the next thing to do here. Tangent squared theta plus 1 is secant squared theta over cosine theta. We can simplify this even more. But no, that's enough. That's enough. But we're just going through the suggestions. And one last suggestion. In reality, there's a lot of suggestions. I just took out the other ones, but there's more. But and we just gotta do this. We always keep an eye on on the goal. What's the goal? You gotta think ahead. That's the last suggestion. What are you trying to do? What's the whole point of this? Okay, we'll do a problem now. All right, ready? Here we go. We're going to start doing some problems. Okay, problem 1. Here we go. Okay, so here's the rules to this game. This is easier. Again, I don't know. Relatively, I don't know what easier means, but for it's easier because you already know what you're trying to prove. What you're trying to prove is the left side equal to the right side? Is this left side equal to the right side? And so you're trying to make something that is complex simple. You don't want to make anything that's simple more difficult. All right? So when I ask, hey, work on the more complex, more difficult, make it simple, because it can't get any simpler than one. That's as simple as it could get. So we're trying to prove that this left side is equal to, is the same as 1. So let's do that. Okay, here we go. Let's follow the suggestion. And I'm going to see if I remember the suggestion. Let's do these suggestions. Suggestion 1 for tangent theta. What was suggestion 1? Change it to what? Sine theta or cosine theta. Continue on. Suggestion 1. What's suggestion 1? Change it to sine or cosine. But what's the cosecant theta going to be? Sine. Not just sine, but what? 1 over sine theta. And cosine theta. What did I say about cosine and sine? They're as simple as they could get. Don't change those. Leave them alone. And then answer. What?
You didn't say that. That's as simple as they could get.
I said that yesterday. I said that sines and cosines are the simplest. You don't ever make them more complex. That's as basic as it could get. Huh?
That would have made the homework so much easier.
No. All right. So what can we do here? We can put it on the one here. Yeah, sines and cosines, don't try to make them more complex. They're as simple as they could get. All right. So what can we do? What else can we do? And so what's the answer? Is 1 equal to 1? Check. That's all there's to this. But you, so it's a check mark, like a check, like yes, the left is equal to the right. It verifies. So basically, somebody's gonna say, is this, and they give you this, is that equal to this? And then you work on the more complex one, make it more simple until it becomes like simple. But you already know what you're looking for. You try to make either the left equal to the right or the right equal to the left. Okay, here's another rule. Another rule to this. You cannot move things around. You cannot move things over there. And this is kind of like this. You cannot cross this. That's why I draw a line. You just want to keep working on one side until it becomes like the other, it equals the other side. All right, let's go to number 2. And there's not one way of doing it. There's definitely more than one way of doing this. Okay. Where should we work? Should we work on the left or on the right? We want to work on the more complex, make it simpler. Which one is more complex? The left or the right? The left. So we're going to work on the left. Because we want to make this look like sine squared theta. Okay. How are we going to do this? Isn't there a secant squared theta minus 1 equal to something? Didn't we just barely do something like that? You got to be very familiar with those. What is tangent squared theta equal to? Oh, what's tangent squared theta plus 1 is equal to secant squared theta, wasn't it? Yes or no? Look at your notes. Is it one of them? Look at your notes. Yes? So, secant squared theta minus 1, I'm going to subtract. Didn't I just do that right now, like in the warm-up or something like that? Isn't secant squared theta minus 1 equal to tangent squared theta? Look at the warm-up. Look at the warm-up. Yes or no? Yes? So what I'm going to do is I'm going to replace secant squared theta minus 1 with tangent squared theta over this secant squared theta. Now I'm going to follow that rule number 1. What the suggestion number 1? What was that suggestion 1? Change everything to sines and cosines. So what's tangent theta? Square means that I'm going to square whatever sine and cosine is, but tangent theta is what? Sine over cosine. So tangent theta is sine over cosine, but since it's squared, I'm going to square each one of them. Yes or no? Yes. What's secant squared theta? Well, again, don't worry about the squared. We're going to square whatever. It's still suggestion 1. Change it to sines and cosines. So what's secant theta? Not just cosine is what? 1 over cosine. So this is going to be what? 1 over cosine what? Squared theta. Now we got a fraction over a fraction. What can we do? Cancel out the cosine squared with the cosine squared. And now what's the answer? Sine squared theta over, which is just what? Did it equal the right side? It's kind of like I just said before. It's just a Rubik's cube. It's like somebody giving you a Rubik's cube and said, "Hey, make it look exactly like this." And you're like, "Okay, I think I can make it look like that." That's all. You so make it look like that. All right, number 3. Let's go to number 3. What are we going to work on, the left or the right? The left. Yeah, some people try to do some weird stuff. Don't do this. This is, again, I'm already, and I don't even know why I'm going to do this, but people do some stuff that's like, no, that's not, go like this or something. And like, what are you doing? That's not, makes no sense. What's 1 plus tangent squared theta? We just played with that one right now. We just did it. What was it? Secant squared theta, wasn't it? We're going to go with that. Secant squared theta. And I'm going to go with the same way I just did this one. It's the same one. It's the same one, except look, tangent squared theta is on top, secant squared theta is the bottom. It's the same one problem, except it's the reciprocal. Secant squared theta is what? Well, they change it to what? It's going to be 1 over what? It's right here. What did we say secant squared theta was? 1 over cosine squared theta. And this is going to be the bottom tangent squared theta. I said the tangent is going to be what? And what are we going to do? We're going to do cancel this. The answer is 1 over sine squared theta. 1 over sine squared theta. And what's 1 over sine? CSC theta, but there's two of them, so it's going to be CSC squared theta. And CSC squared theta, CSC squared theta. We're done. Okay, so I stopped there.